Have you ever been kept up at night by a mind-bending puzzle that just doesn't seem to have a solution? Well, imagine being a scientist grappling with paradoxes that challenge the very fabric of reality itself. These paradoxes are not just intriguing thought experiments, they're the stuff that keeps scientists tossing and turning in their beds, searching for answers that seem to slip through their fingers like grains of sand. Join us on a journey through the 8 strangest paradoxes that haunt the minds of scientists, leaving them pondering the mysteries of the universe. But before we delve into these enigmas, let's first understand what a paradox is. At its core, a paradox is a statement or situation that appears to contradict itself, yet holds a certain truth. It's like a riddle wrapped in a mystery, challenging our understanding of logic and reality. Paradoxes often defy conventional wisdom and force us to question our assumptions about how the world works. Now, let's explore 8 most mind-bending paradoxes that perplex scientists to this day. 1. Fermi Paradox. Named after physicist Enrico Fermi, this paradox ponders the apparent contradiction between the high probability of extraterrestrial life and the lack of evidence for or contact with such civilizations. In a universe teeming with billions of stars and planets, where are all the aliens? This question leaves scientists pondering the possibilities of cosmic silence. 2. Bootstrap Paradox. Imagine a time traveler who goes back in time and gives Shakespeare a copy of his own plays. Shakespeare then publishes them, and they become famous. But where did the plays originate? This paradox questions the origin of information and events, creating a loop with no discernible beginning or end. 3. Grandfather Paradox. If you were to travel back in time and prevent your grandfather from meeting your grandmother, thus preventing your own birth, how could you have traveled back in time in the first place? This paradox explores the implications of time travel and the potential for paradoxical situations to arise. 4. Taking out Hitler Paradox. Similar to the grandfather paradox, this scenario involves traveling back in time to eliminate a significant historical figure, such as Hitler, before they can commit atrocities. But if Hitler never existed, what would motivate you to go back in time to eliminate him? 5. Polchinski's Paradox. In the realm of theoretical physics, Polchinski's paradox specifically addresses the concept of cosmic strings. Cosmic strings are incredibly thin, incredibly dense objects, stretching across vast distances in space. These strings are remnants from the early universe, formed during phase transitions shortly after the Big Bang. They are hypothesized to be one-dimensional structures with immense energy density, potentially capable of warping space-time around them. According to some theoretical models, cosmic strings have the ability to self-destruct through a process known as gravitational radiation. Here's where the paradox arises. If cosmic strings have the capability to self-destruct via gravitational radiation, why do we still observe them in the universe? In other words, if these strings can annihilate themselves, shouldn't they have all disappeared by now, leaving the cosmos devoid of such structures? This paradox highlights a fundamental tension between theoretical predictions and observational evidence. 6. Observer's Paradox. The observer's paradox is a mind-bending concept in the realm of quantum mechanics that explores the role of observation in shaping reality. Let's break it down with a simple example involving a classic experiment: the Schrödinger's cat thought experiment. Imagine a sealed box containing a cat, a vial of poison, and a radioactive atom with a 50% chance of decaying within a specific time frame. According to quantum mechanics, until the box is opened and observed, the cat exists in a superposition of states, both alive and dead simultaneously. Now, here's where the observer's paradox comes into play. When the box is closed and no one is observing it, the cat's fate remains uncertain, existing in a state of limbo. However, the moment someone opens the box to observe the cat, the quantum superposition collapses, and the cat is found to be either alive or dead. Here's the paradox: if the act of observation is necessary to determine the cat's state, what happens when no one is there to observe it? Does the cat remain in a state of superposition indefinitely, existing in a bizarre limbo between life and death? In essence, the observer's paradox invites us to ponder the fundamental mysteries of existence and the intricate interplay between observation, consciousness, and the fabric of reality itself. 7. Double slit experiment. One of the most famous experiments in quantum physics, the double slit experiment, reveals that particles like electrons can behave both as particles and waves. When shot through two slits, they create an interference pattern on a screen, suggesting wave-like behavior. However, when detectors are placed to determine which slit they go through, the interference pattern disappears, indicating particle-like behavior. This paradox highlights the observer effect. The act of measurement changes the outcome. It challenges our understanding of the fundamental nature of particles and the role of observation in shaping reality. 8. Black hole information paradox. According to quantum mechanics, information cannot be lost, yet black holes seem to violate this principle by absorbing information and trapping it behind their event horizons. So the black hole information paradox arises from the conflict between two fundamental principles of physics: quantum mechanics and general relativity. According to quantum mechanics, information cannot be lost, yet when matter falls into a black hole, it seems to disappear without a trace, violating this principle. This paradox suggests that black holes destroy information, leading to a breakdown in the laws of quantum mechanics. Proposed solutions, such as Hawking radiation, imply that black holes can eventually evaporate, but they fail to explain how information is preserved. These paradoxes represent the frontiers of scientific inquiry, pushing the boundaries of our understanding and challenging us to think beyond the constraints of conventional wisdom. For scientists, each paradox represents a tantalizing puzzle waiting to be solved, a mystery begging to be unraveled. Yet, despite decades of research and countless sleepless nights, these paradoxes continue to defy easy explanation, leaving scientists humbled by the vast mysteries of the cosmos. In the end, perhaps it is the pursuit of these enigmas that drives scientists forward, inspiring them to seek answers beyond the known boundaries of human knowledge. And as long as there are paradoxes that refuse to be resolved, there will always be scientists driven by an insatiable curiosity to unravel the secrets of the universe. So let us embrace these paradoxes, for they remind us that the quest for understanding is an endless journey, filled with wonder and awe.